Hello and welcome to this episode of Lutra TV. Today we're going to be talking around process optimisations. Joining me on the couch is Jonathan Church, our Principal Process Engineer for Water Treatment, and my name is Quentin Griffiths, Chief Customer Officer here at Lutra. So John, before we get into this, tell me, what are process optimisations?
Well, it's a pretty complex subject, Quentin. There's a lot of different things that could be called a process optimization, and it's definitely one of my pet loves is to make plants work as well as they can. But in essence, what a process optimization is it's getting the most bang for the buck.
Yep.
It's getting the most efficiency possible. It's using the least resources. It's getting insights into how your plant works and being able to use those insights. So, yeah, a complicated topic. And often in the end, it comes down to money. It's an ability to save money by using what you have more efficiently.
So I guess, how would you go about, what are the first steps when you start considering looking at process optimisations, and how would you go about, understanding and then, implementing? Yeah,
so to understand what can be optimised in the first place, I think takes a pretty good understanding of how, say, a water treatment plant's performing, and picking one or more areas at the plant that you want to improve. Things like chemical dosing is a classic one. Water treatment plants, because of the sensitivity around drinking water standards, they tend to be quite heavy-handed in the use of chemicals. And it's often quite achievable to improve the chemical usage in some area, whether it's coagulant or pH control or something like that. And things like polymer, all of that comes down to how does the plant work, and is it possible, and how far can you go in, say, reducing chemical usage?
Yes, yeah. So when you say heavy-handed on chemical usage, is that generally an overdosing type scenario?
Yeah, well, it's one of those things. We're not typically talking about like overdosing as being a massive overdose. It might not be much, might only be 5%. But if you can understand the chemistry of your water quite well, then you can optimize the dose rate to be exactly as much as you need, rather than a little bit more. And that 5% or whatever it is might add up over time, and save you money in the long term. And another area might be, say, the waste, be it water or solids that a plant is generating. Like, plants have certain levels of efficiency. Water comes in, waste goes out, solids are produced. Things like reducing the coagulant can thereby also reduce the solids that are produced. And also by improving things that are not necessarily relating to the dose rate, but things like the strength of the flock, and the performance of filters or clarifiers, it can actually mean that you don't need to backwash as much on your filters, therefore you generate less water waste, therefore you produce more treated water and you make the plant more efficient.
Yeah, and I know just from some of the work I've done in more of the data space, another type of example which I've seen more of is even around, becoming a little bit smarter around how you operate your plants as well. So not even on the chemical dosing side of things, but if I think of smaller plants where they're running, let's say they're topping up a reservoir or something like that, and just that switching of the plant on and off and that run to waste in that time to top up reservoirs and the likes, looking more at your demand forecasts, understanding what that typically looks like, and trying to reduce that switching of the plants.
Indeed. So in terms of the way that the plants are operated, to be able to improve it, you've got to have a pretty good understanding of what's going on. And the first place to look for that is your online analyzers, and basically your historical knowledge about how things perform in certain conditions. In regards to like plants, the way plants are operated, it's using things like demand forecasting can mean that you can reduce the cost, given that you may produce water in the middle of the night where, say, electricity is cheap, pumps are cheap, versus, in the middle of the day when demand is high, but electricity is more expensive. So yeah, absolutely. Sort of wider control schemes can help with process efficiency.
Yeah. And look, I think you've mentioned a couple on there around the whys, but why would you generally look to do a plant optimisation?
Well, that's a really good question, because a plant may be working just fine in regards to the traditional metrics, like filter turbidity, for instance. The things that matter for safe, compliant water. But the reason that you'd want to do it is because, given minor changes in plant operation, you can save reasonably significant amounts of money.
Yes.
And by doing so, it's kind of improving the holistic operation of the plant. You're making the most with what you've got. And given enough time span, the savings can be quite large.
Yes.
So in this age of I guess resource usage, etc., you're making the most of what you've got and use it for the least resources. So
yes,
yep.
yes. Have you got any specific examples from, I guess, your experience in the field of some optimisations that have gone really well?
Yeah, so I mean, a very common one would be optimising, say, clarifier turbidity. Clarifiers, by their nature, they remove the primary amount of solids. But if you have slightly higher, say, turbidity coming out of a clarifier than you might necessarily be able to achieve, that translates directly downstream to the filter performance, the backwashing, all that sort of thing.
Yes.
So the cause of that performance might be anything. It might be the way the plant flow is controlled, causing carryover. It might be the type of polymer that's used,
yes,
causing the flock to rise up too much, or the dose rate of that polymer. It might be the coagulant dose rate. There's a lot of different things, but whichever one it happens to be, tweaking it just right means that, you may save money on the chemical being dosed, but also, reduce the effect on the downstream. And in some cases, you might even improve the performance of the turbidity off those filters.
Yes.
To use that drinking water standards example, because you achieve a better flock and a stronger, essentially, a stronger material. So the performance actually goes up. In terms of the drinking water standards type thing. Yeah.
Have you ever seen optimisations or done work on plants where perhaps it hasn't gone so well?
I mean, in terms of not going so well, I think the biggest pitfall is when the answer turns out to be that a chemical or an improvement, let's say, is going to cost more.
Yes.
For the council that's operating the plant. That might come with usually that comes with some sort of benefit.
Yes.
In the case of, like, say, weighing water production or efficiency up against against the cost of adding more chemicals. But in my experience, mostly there's some savings to be had somewhere in most treatment plants. It's just a question of information and having the right information about what you're trying to achieve, be it via sampling, online analyzers, the control system at the plant, whatever it happens to be.
Yeah, yeah. And I think that's probably important, again, coming at this from more of a data type angle, is I guess getting that really deep understanding of what the plant is actually doing before trying to go down these paths. So actually understanding how it's operating, what kind of efficiency levels you're actually achieving, and also, I guess, kind of going back to your point, whilst it might not always be a money-saving exercise, you may get other optimisations at the back end. So whether that be better performance on filters or on the actual outcome in terms of drinking water standards, or even or how much waste you're actually doing there. So whilst we talk about optimisations, it's not always going to be a cost saving. There could actually be a performance aspect to it as well.
Yeah, and sometimes on the other side of the coin, the cost savings for doing the small things can be massive. To give one example, which is a pretty common discussion in New Zealand these days, is carbon dioxide dosing.
Yes.
To optimise that requires a very detailed knowledge, I guess, and quite a high level of understanding what your raw water source is.
Yes.
But if you can do that, then you can save CO2, and immediately that saves the amount of pH correction that you might be dosing.
Yes.
It can save the downstream chemicals.
Yes.
And that essentially flows on through the whole plant. But key to that is understanding why you're dosing the CO2. Is it for coagulation? Yes. Is it to protect your reticulation? All of that feeds back to how you're going to control it, and how much information you need on that raw water source.
Yeah. I think also, as we as you mentioned before, that sort of resource scarcity, and as we're becoming a lot more aware of our carbon footprint as well, I I guess that's where kind of that deeper understanding, potentially optimizing that chemical dosage, or even reducing the amount of energy we're using also kind of helps that longer term, carbon story as well. So potentially reducing what the emissions of plants and the likes are. So particularly I've seen that in, I guess, more the wastewater realm as well, that once you start understanding these things, you choose your optimization goal, whether it be a money saving, efficiency gains, or whether it might be a carbon sort of goal. So kind of defining those goals up front, understanding what you're trying to achieve, and then I guess putting the resources in to understand that.
Absolutely, yeah. The way that plants operate, people often think of electricity, and it's New Zealand is a renewable country generally for our electricity production, but the chemicals that are used in these plants all come from overseas, or the majority.
Yes.
And are probably quite heavily intensive on the carbon side of things. So doing the kind of carbon balance also adds an argument for doing a process efficiency improvement.
Yes, yeah, exactly. All right, brilliant. Well, hey, look, thank you for your time today, John. I think it was great. Good to understand what is achievable. And if you'd like to find out more around what Lutra can do in this area, please don't hesitate to reach out. Otherwise, please like, subscribe, and tune in for our next episode. Thank you.